The join and spatial joins are powerful operations in ArcGIS Pro so we can combine multiple geographic and tabular data layers. The spatial join is a GIS operation that merges two spatial layers based on spatial relationships between their geometries. It's similar to a table join in a relational database, but instead of a common key, basically this key is location. We're going to look at a couple examples here where we look at cancer deaths within NC counties, and then we'll look at CAFO, concentrated animal feed operations locations within watersheds. What we're looking at here are NC cancer deaths across the entire state of North Carolina. If I right mouse click and open my attribute table here, you can see some of the information we have for it. For the 102,000 cancer deaths, and we received this about 10, 12 years ago from an IRB, Internal Review Board, through the Department for Health Statistics. You can see the information doesn't have any individualized information about about addresses, people's names, or anything. So you can see the date of birth, age units, and what we're going to do here is we're going to group all of these by county. So if I uncheck this, you can see that I have a spatial data layer of all of North Carolina's 100 counties. And essentially what I want to do is just count the number of cancer deaths by county. Now I can do this using a select by location and do it 100 times. That would be really difficult and really tedious. And so what we're going to do here is we're going to run a spatial join based on location because I can see birth county, I can see some other things here with the summarizes, but I need to match up these birth counties with other places, and it gets really, really difficult in order to do this. Other information I have here is the death date, the sex, the race, the state, and then the code, ICD code for this particular cancer death that we can look at from the North Carolina Department for Vital Statistics if we want to see exactly what we're looking at here. But we're just doing this example right here, and all the way at the end we have the age units attached to the age of the decedent. So we're also going to be running some summary statistics on these as well using this age units. So what we're going to do here is we're going to count the number of cancer deaths by county, and while we're doing it, we're going to average up the age of death for each of the decedents right here. I'm going to right mouse click, and I'm going to go to joins and relates, and I'm going to go add spatial join. Now, the reason why we're creating this video is because we're working with ArcGIS 3.3. In previous incarnations of ArcGIS Pro software, it would create independent or brand new feature classes attached to these. Now these joins are going to exist in my NC county, so I can create this spatial join and then get rid of it or release that spatial join so it doesn't exist anymore, instead of creating an independent and brand new feature class attached to it. So my target features are going to be my NC counties. My join features are going to be the NC cancer deaths. Each of these represented as points, one of about 102,000 individual points. My match option is going to be intersect. And if I wanted to, I could set up a search radius based on decimal degrees or other units that we're looking at here. But we're just going to look at these that lie entirely within the county. The other thing that we're going to have here is fields. And you can see my fields right here, and this field editor and this field query is going to be a little bit different. And like I said before, what I want to do here is under these ages, I want to run the average of all the ages by counties as well. So not only I can map the number of deaths by county, I can normalize that by population, but then I can also look at the average age of each decedent. First thing I'm going to do is, and one of the things I want us to get in the habit of doing is removing any of the extraneous material right here. Okay, so when we look at birth county, because when we add these, it's going to get this spatial join is going to get increasingly more confusing. And there's a number of different statistics that we can run, and I'm going to highlight these here in a second. Okay, so under the age, you can see my field map. I'm going to click on edit. And then here's my editor right here. So I have age. Here's the alias. It's a double. And what I want to click on here is I can get the first, the last, when we're looking at nominal data, the min, the max, the sum, the mean. What I'm going to look at is the average. Now I can do multiple for the age. I can add multiple statistics related to these, but I'm just going to click on the average. So once again here, the mean of the age. So as we're counting these deaths by county, we're also averaging up the age units. I could also look at other statistics attached to age. I can look at the standard deviation to look at the amount of variation. I could look at the range of these. I'm going to keep this really simple for now. And when I'm set, I'm going to click OK, and I'm going to run it. X out of cancer deaths. I'm going to right mouse click, and I'm even going to uncheck this here. So now I'm going to right mouse click. My attributes, now I have my NC counties with my POP 2010, POP 2013, all of my demographic data attached to these here. Now when I go to the right here, I have something called the join count, target ID, which we don't need to worry about, and these age units right here. So I can right mouse click, do sort descending, and so I have a county here, Mecklenburg County, Wake County, Guilford County, that have the most number of cancer deaths. And then this is the average age at which our cancer decedents die. And so these are going to be spatial in nature as well. But what we're looking at here, this new resulting data exists within the NC Counties feature class. So if I wanted to, I could right mouse click joins and relates and remove all these joins, and this would disappear instead of adding a brand new feature class that I need to manage. Now, like you saw before, I got rid of all the extraneous units. So I only kept the age units, and then I have this join count. In previous incarnations of ArcGIS, you might see something called frequency. I've got the target ID and the shape length, because you can see the FID for this as well. Now, I can make some simple maps right here, and then we'll look at the next example. So I can go to symbology. Under symbology, I'm just going to do graduated symbol. And now when I go down to graduated symbol, now I can look at join count. And now I can see the counties that have the most number of cancer deaths right here. And I'll X out of this. And I can make a map here, and you can see the labels attached to these. I can normalize by POP 2013. So now we can see where cancer rates are the highest. And so you can see here in northeastern North Carolina, you can see cancer rates are really high over here. Out in western North Carolina, they're really high here. And we can run some age grading procedures on this, so we can basically normalize by age or age grade these to see where these age graded death rates occur at the highest rates. Because obviously, cancer rates may be higher out here because it's got an older population. And then lastly, what we can do here for this particular data set is, instead of join count, I can look at these age units. I can run no normalization here. And now you can see these are spatial in nature. So now we can see the average age at which our people die of cancer within each of our counties right here. So this is a great example of some of the statistics that we're able to run. Really good examples of some of the statistics that we're able to run. Now, in some cases here, we can map these by county. In other cases, well, counties won't be applicable here. So what we're going to look at is CAFO's, concentrated animal feed operations. And if I right mouse click on this, we can open the attribute table. And I downloaded this from North Carolina One Map. So this is downloaded from North Carolina One Map. This is a data repository of all the data or data at the state level kept. And I can download this. This is good as of about 2023. So you can see all the information for the 2,479 concentrated animal feed operations. These are permit sites. You can see the owners, last inspected, allow, count, factor. I don't know what those necessarily mean, because we're going to look at different types of operations here. Now, when we think about it, does it really matter if we group these by county? Probably not. So what I did was I went and downloaded watersheds. Let's see how much each of these CAFOs are contributing to each of the watersheds. Now, these watersheds are collected at the HU6 level. So these are hydrologic unit codes. And so HU6, 2 are very coarse and get finer and finer and finer. So if I right mouse click on the attribute table, you can see there's 14 of these different, I believe these are called basins, watersheds or basins that lead to the ocean in North Carolina. And this is going to be important because where we have more CAFOs, more of this swine or dredge or whatever we're talking about here is emptying into the ocean depending upon which one has the most. And we're going to run some other operations on this too. So we're going to see which one of the watersheds in the state of North Carolina has the most number of CAFOs leading to it. And while we're there, I saw an interesting value here on allowable count. So if I look at this allowable count, so we're descending, maybe this is wet poultry or cattle or whatever we're looking at, or total live right here. So we can look at these different factors here. So maybe we'll look at this total live and sum all these up to see how much is going into each of these watersheds to look for water contamination, groundwater contamination, things that, some things using some GIS operations right here. Okay, and we're doing this because counties aren't going to be applicable for this. So once again, we're going to do the same thing. So we're going to right mouse click. We're going to do our joins and relays. We're going to add a spatial join here. And my join features this time are going to be my CAFOs. Under my fields, now what we're going to look at here, under my CAFOs, we'll look at total live right here because this looks like allowable count, which is wet poultry, layers, non-layers. And so it looks like this number times this number looks like the total live, because I would imagine these factors will be increased for swine to look at the amount of impact and the amount of impact that are going into the watersheds, into the groundwater and surface water and whatnot here. And so what we're going to do here, we're going to look at this we're going to look at this called total live. And we'll go back to the symbology here. So we'll get rid of everything else. And we can look at the number of different permit types or anything else that we want. X out of these. And I'm just doing this to make it a little bit easier. Now, under this allowable count, how about while we're here, why don't we click the sum of these? We don't need that factor. And this total live, while we're here, we'll do the sum of these as well. And so now we have allowable count. We'll click on mean. And the lives. And so I can navigate here in the fields that I'm looking at as well. So allowable count, we'll look at the mean, total live, we'll look at the sum, just to look at the average per watershed. And when I'm set here, I'm going to click OK. Here we go. So we'll uncheck the CAFO, right mouse click. Under our attribute table, once again, we have the information about the 14 watersheds that we have here. And what do we have? We have a join count. So this is the total number of CAFOs by watershed. So we can see the Cape Fear, Neuse, Lower PD, Upper PD have the most. Allowable count, that's the average number per farm. And then this total live is that multiplier times the allowable count, because it looked like chickens were weighted less than swine, than cattle or whatnot. And so we can look at the total contribution to each of these watersheds. So once again, we'll do the same thing. Look at these, right mouse click, click on symbology. And now at the watershed level, we can do the same exact thing. Graduated colors. Instead of acres, we can look at the join count. And here we are for the join count right here. So now we can see which of the watersheds has the most number of CAFOs within it. If I wanted to, I could, we can see where these are located. I'll go back to put a single symbol right here. I'll get rid of the labels. I'll change it to a single symbol. I'm doing this over here. So instead of, I'll get rid of the graduated colors, I'll make it a single symbol. There we go. So we can see where this Cape Fear watershed is in North Carolina. So this is the total number of CAFOs here by watershed. I can click on my symbology as well. Instead of join count, let me look at that total live, because that's what we really want to look at, the total amount of contribution into each of these watersheds. And you can see this lower PD is relatively high because we don't have the information for South Carolina. We're specifically looking at North Carolina. So we need more information because we know that watersheds don't have judicial or administrative boundaries right here. And so once again, you can see the Cape Fear has the highest number. Now we can get these for smaller and smaller watersheds that contribute to the Cape Fear, the Neuse, the Pamlico, the Roanoke, lower PD, upper PD. But you can see just some general estimation of these here for the state of North Carolina. So in summary, this is a good representation of using ArcGIS Pro 3.3 with the new functionality to run the spatial join, essentially counting the number of points within each of the polygons. And while we're doing it, adding up statistics, adding up variables and fields that are going to be important to us to facilitate data-driven decision making.